It's 1979 when The Clash released London Calling, Pink Floyd released The Wall, and the Voyager 1 probe recorded, for the very first time, the magnetic fields of the gas giant Jupiter. Yes, you are currently listening to a planet sing, and yet we can hear each other. No one would be able to hear you scream if, just like magic, you were teleported into space. Because space can be considered, for the most part, as empty. But that doesn't mean that nothing can be heard there. So, if in space no one will hear you scream, maybe it's mainly because we are deaf to certain types of melodies. But thanks to the use of extremely powerful sensors, acting like powerful amplified hearing aids, amplifying the sounds of space, we are now able to listen to celestial bodies sing. If you're in a contemplative mood, you can skip ahead 1 minute in the video to go straight to the planet's magnetic fields. Otherwise, to understand why, here's the explanation. Sound, by its nature, is a vibration that relies on matter to propagate in the form of a pressure wave. And since you can make almost anything vibrate, sound can travel through air just as it does through water, through rocks when they shake, as well as through metals or any material with more or less efficiency as long as there is matter. On Earth, at sea level, there are about 27 billion atoms per cubic centimeter of air. And sound can easily travel through it, whereas in space, it's obviously a completely different story. Yet, strictly speaking, the medium that fills the space between planets and stars is not perfectly empty, although it is extremely sparse. For example, in the interplanetary medium, densities of a few dozen to a few hundred particles per cubic centimeter on average have been measured. Even at the altitude where the International Space Station orbits, this density is about 50 million atoms per cubic centimeter. But let's get back to space. These particles we've talked about are so sparse there that they don't really touch each other the way they would on Earth. But most of them are charged and in motion. They produce both electromagnetic fields and waves. They influence each other, a bit like the ones in our atmosphere do when they collide. So even though the sounds as we know them have disappeared here, there are still vibrations, faint pressure waves that travel through this almost deafening silence. Thus, some instruments on board space probes are sensitive enough to record the vibrations and oscillations of electromagnetic fields, which can then be translated and converted into frequency ranges audible to humans. And so, these ultra-sensitive listening devices give us access to a whole range of auditory experiences that go beyond our biological limits, allowing us to listen to the highs and lows of a vinyl record written by the activity of a planet. This process, called sonification, involves interpreting and translating the collected data into harmonics, pitch, or duration in order to construct soundscapes of space, and it may seem artificial to you. Remember, every sound is just a vibration traveling through the air, reaching our eardrums. If the vibration is within audible frequencies, our eardrums convert it into electrical signals, which our brain then interprets. But originally, these vibrations can come from anything and everything, whether it's the movement of vocal cords, a bird, or a pot and a hammer. And in this regard, the Earth is no exception and also has, through its magnetosphere, a unique musical pattern. Is it? You are not currently hearing the sounds of life in the heart of a humid tropical forest, but rather the voice, the magnetic field captured in a recording made several thousand kilometers above the Earth in space. In other words, you are listening to the sonification of the Earth's vocalizations when the solar winds strike its powerful protective magnetic field. As for this particular Star War, it was recorded by the instruments of a little-studied dark region, the Van Allen Belt, which also stretches several thousand kilometers. You can hear the whistling of charged particles spiraling along magnetic field lines and echoing the signals emitted by the movement of high-energy electrons. but also the electromagnetic waves and the jolts of plasma, which, created by lightning discharges in the Earth's atmosphere, then travel along the field lines. Through the extremely thin and charged gas drifting in space. And here we are now, in front of the gas giant Jupiter, a planet that has also been heard in its own singing way. When, on June 24, 2016, the Juno spacecraft reached the bow shock marking the surrounding space, and the beginning of the magnetic field, 10 times more powerful than that of our planet, produced by the giant. For about 2 hours, it records the crackling of an invisible war between the charged particles coming from our star and Jupiter's magnetosphere. A magnetic moment 18,000 times larger than that of Earth, and if it shone in visible light, it would be twice the size of our full moon as seen from our world. About 3 months later, as the probe approached within about 4,200 kilometers of the tops of the swirling clouds, it made these strange recordings, the playback speed of which has been slowed down by a factor of 60 here to make them accessible to us. If this audio track may seem meaningless to you, for those who are familiar with it, listen and decipher these crackling whispers. It is possible to hear the undulation of charged particles moving through Jupiter's ionosphere, as well as the intense activity of the gigantic storm cells swirling around the pole. Thus, it is by precisely sampling the thermal radiation coming to us in the form of microwaves from the top of the ammonia clouds, as well as from deeper regions of the gas giant's atmosphere, that we can deduce parts of what is happening beneath the thick cloud layers of Jupiter's upper atmosphere. Nearly 35 years earlier, the Voyager 1 probe had already given us, during a flyby of this turbulent world, the chance to listen to the Jovian chorus. The sounds you hear here come from streams of electrons spiraling along the magnetic field lines encircling the planet. As for this recording, also made by Voyager 1, it was the very first to provide indirect evidence of powerful lightning on Jupiter. These floating waves that you can perceive are produced by lightning, which, in the planet's upper atmosphere, propagates from the poles along the field lines of the magnetosphere. Jupiter isn't the only planet with lightning. We have also been able to listen to them on Saturn. This excerpt comes from a recording made by the Cassini-Huygens probe. And you can hear the crackling of lightning, or more precisely, a condensed version, because the real-time duration of this recording had to be compressed by a factor of 260 for us to be able to hear it. In other words, the 28 seconds of lightning crackling you are hearing are condensed from nearly 2 hours of recordings made by Cassini. 2 hours during which the probe detected on average 1 lightning strike every 2 seconds in Saturn's clouds. And just like with Jupiter earlier, nearly 30 years before, Voyager 1 and 2 had already passed by, their antennas pointed near the ringed giant. The first one also recorded deep lightning there for the first time. Lightning that, when it strikes, generates strong impulses similar to the crackling you can hear on a radio during thunderstorms. As for the second one, the Voyager 2 probe, it made this recording during its approach to Saturn. You can hear the magnetic rumblings of the gas giant, picked up by the onboard detectors as the probe is about to pass 110,000 kilometers from the planet. Here, these sounds are transcriptions of the interactions between charged particles from the solar wind and the powerful magnetosphere surrounding the planet, shifted into a range we can hear. And the movement of these charged particles, like the strength and direction of the currents, are translated into electrical signals which are then amplified and used to excite the membrane of a speaker that you are listening to. And in the same realm of strangeness, the Juno probe, during a particularly close flyby of Jupiter, picked up radio signals emitted by the intense polar auroras. Known as Jovian kilometric emissions, these signals have wavelengths nearly a kilometer long. And to be made into digestible audio, the recording we're currently listening to had to be compressed to the point where 13 hours of capture fit into just about 25 seconds. Let's make another leap through space and time to find ourselves once again near Saturn. With this other recording made by the Cassini probe, which lets us listen to intense radio emissions coming from the giant planet Saturn, and whose existence proves that this planet also has polar auroras. Here, the emission frequencies, well above the range of what we can naturally perceive, had to be shifted down by a factor of 260, resulting in these strange, ethereal layers of sound. Here, the emission frequencies of these other recordings of Saturnian auroras by Cassini had to be shifted down by a factor, 44, and this time, the duration was compressed nearly 22 times to be heard, so that 27 minutes of recording made by the probe end up being transformed into just 73 seconds of listening. However, not all the sounds captured in space are necessarily modified to be listened to. This soundtrack, recorded by Voyager 2 as it approached Jupiter, is 27 minutes long in its full version and is made up of authentic sounds with their original frequencies, which have not been altered to make them audible to us, nor stylized. Some sounds you hear are from the probe's internal instruments. The constant background tone, which is slightly unpleasant, comes from the spacecraft's power supply. The very faint, muffled percussion sounds come from the probe's thruster, while others are produced by modulations from a measuring instrument. But all the rest of this strange hubbub, is made up of signals of natural plasma waves detected by Voyager 2. These are the true sounds of Jupiter, its magnetic field, which give us its voice. And since I've long since exceeded my quota of space ASMR, I think it's high time to end this episode by getting hit head-on by a wall of sound. Listen closely, that chirping sound was recorded by Cassini when it crossed, on June 27, 2004, a strange floating wall located nearly 3 million kilometers from the gas giant. The presence of this type of shock front is not unique to the ringed planet. We have already talked about this at length. It is found everywhere. The encounter between particles carried by the supersonic solar wind and wells without a magnetic field results in sudden changes in the intensity of the electric field. That's why, as a final ASMR, I would like to share with you the most distant audio recording ever directly made by a machine built by humans. Here you are now, with 30 seconds of crackling, full of little flourishes, captured by the instruments on board the probe. Voyager 1, when it reached the edge of our solar system, at the limits of the heliosphere, and entered the interstellar medium that fills the space between the stars. You can hear the amplified variations of vibrations from the interplanetary plasma beyond the magnetic influence zone of the solar system. And even here, several billion kilometers from Earth, this extremely diluted plasma soup. This interstellar medium, which is one of the most pronounced vacuums we know, and in which there are on average 0.3 atoms per cubic centimeter, can be heard. If you enjoyed this episode, follow me on Insta, subscribe, and click the bell in whatever order you like. You can also slide over here to experience a rather perilous adventure toward the heart of planet Jupiter.